The next part is piecewise functions. So piecewise means we're just splitting things up into pieces and then using different functions for different slices. Okay, so if we look at here, f of x is x squared when x is less than or equal to 0. So anything that's less than or equal to 0, we're going to use this. But for anything between 0 and 2, not including 0, it's going to be 4. And then otherwise, it's going to be x minus 1. So if we're trying to find f of negative 3 and f of 1 and f of 5, we have to see where it fits in here. So for the first one, f of negative 3 is less than 0. So we plug that into here. Okay, so we get negative 3 squared, which is 9. F of 1, however, is in between 0 and 2, so f of 1 is going to be 4. F of 5 is here, so we're going to use this function here. So it's going to be 5 minus 1, which is 4. So piecewise just means depending on what the x values are, it's going to be different notations and functions. The next one is graph of a function. So here, if f of x is negative 3 and f of x equals negative 3 plus x squared, and then it's x over 2 minus 1 for greater. So once again, it's split up. So if we look at the graph here, f of x is a constant function when x is less than or equal to 0. So up until 0, it's a constant function at negative 3. Okay, from 0 to 2, the graph is negative 3 minus x squared. And for this part, you can plug in some points. We know that it's a parabola because it's a quadratic, but once again, you can plug in some points to get this part of the graph. And it's a closed dot here because it includes 2. And on the other hand, this is an open dot here because it doesn't include 2. And then x over 2 minus 1 is a line, so you can point plot, you can use the slope is negative or positive 1/2. The y-intercept is negative 1, so you could actually have drawn that line, and since it starts at 2, just leave it from that point on. Okay, so graphing piecewise functions is pretty similar to graphing functions, except now you have to look at different parts with different either lines or parabolas or any other curves. So the difference between this one and the one that you just saw before is that it's only for one value that it is equal to 3, right? So for when x equals negative 2, it's 3. Otherwise, it's this function here. So we graph the function x squared minus 4 over x plus 2. Once again, you can point plot. And then at x equals negative 2, we have to keep a hole on that graph because it's not for when x equals negative 2. And when x equals negative 2, my value is at 3. So here, my value needs to be at 3. Okay, so open circle means it doesn't include it, closed circle means it does. The last thing in section 2.1 that we have is the greatest integer function. So it's denoted f of x is equal to x, like this. And this means that it's the greatest integer that is less than or equal to x. Okay, so for example, the greatest integer of 3.2, it's the greatest thing that's less than 3.2, right? Greatest integer that's less than 3.2, so it's 3. For negative 3.2, it's the greatest integer that's less than or equal to negative 3.2, so that'll be negative 4. So on a number line, so let's have 0, negative 1, negative 2, 1, and 2. So anything in here, right, whether that's 3/4, 0.2576, or anything within, if you find the greatest integer, it'll be 0, right? Because that's the highest integer that's less than any of these values. Same thing on this side. So if I pick anything within here, the greatest integer that's less than or equal to that value, whatever I choose, will be -2, because that's the highest, but it's less than the value that I'm at. Okay, so with positives, it's always going to be, you can just take the positive integer part, but with negatives, as soon as you go over, you're going to have to go to the next one down. Okay, so -3.2 is, let's see, if we extend it, it's -3, -4. -3.2 is here, and so the greatest integer function of -3.2 is going to be -4.